All right, so today we are doing 4.7.1, which is inverse trig functions. So here we're going to take a trig value and then go backwards and find the angle that gave us that value. So as a warm-up, you can work on this quick and then go through the answer. It's just kind of a review of what we did before. Okay, so you want to decide what sine function to use, or what trig function. So if we have SOHCAHTOA, just over a little bit, there's A. Here's our angle. Opposite it is the 5, adjacent is the 12, so we want to be using tangent. So tangent of the angle, so tangent of x, has to equal 5 over 12. And then to get rid of the tangent, you take the tangent inverse of both sides. And you get something like this. Type this into a calculator, and here your answer is going to depend on what mode you're in. So if you're in degrees, you should get 22.62 degrees. If you're in radians, you'll get something different. Unless it tells you specifically, like, I want radians or I want degrees, it doesn't matter which one you have. But just make sure you're reading your questions. So some terminology. We're going to continue to fill this out as the notes go. So I'm not going to do this stuff right now. But inverse sine is also known as arc sine. So if you see arc sine in questions in the homework or something like that, it's the same as inverse sine. It's written like this with a -1 in there. So it's not like so it's inverse versus like something else. Here's arc cosine is the same, arc tangent is the same. These are on your calculator right above the normal sine, cosine, tangent. So if you do the second button and hit sine, you'll get sine inverse. All right, so sine inverse allows us to figure out what is the angle when you already know the ratio. So if we figure this out, here, this is our opposite side, this is our hypotenuse, so you're using sine. So you do sine of x has to equal your 7 over 22. Take your sine inverse of 7 over 22. And again, if you are in degrees, you should get 18.55. If you're in radians, you'll get something else. So a note here with this, the way I like to think of it, is if you do sine of something, you always need an angle next to it, and you're going to get a ratio. So you're going to get your opposite over hypotenuse when you figure out that problem. When you're doing sine inverse, you're given the ratio or the opposite over hypotenuse, and your answer is an angle. And that applies for like cosine and tangent too. So if you have an inverse, you're getting an angle as your answer. If you have just a sine, you're getting a ratio or a number as your answer. It's a good way to like think about the two differences. Okay, so sine and sine inverse are inverse operations, so they undo each other. The same way that like x squared can be undone by a square root, or like multiplying, you can divide to get rid of it. So here, if we're going to simplify these, sine and sine inverse cancel, and you get 0.25 for your answer. And these will cancel, and you'll get 48 degrees as your answer. So take a second and look at these. So this one we say is true, this one we say is false. And try and think about why. Okay, so this one, true, easy, it cancels out, whatever. The reason this one is false is because you can never get 15 as a ratio of cosine. So cosine is your adjacent over your hypotenuse, and the hypotenuse is always greater than the adjacent side because it's always the longest side. So this ratio is never bigger than 1. So this is never greater than 1. So getting 15 as your ratio to begin with is not possible. So that's what it says here. Cosine inverse undoes the cosine operation, but if you start with a cosine ratio greater than 1, it's not possible. You can't do that. It's kind of like starting out with like a negative number and trying to like you have negative apples, and then how many apples do you have? Like you can't, it doesn't make sense kind of thing. Okay, So some more terminology here, domains and ranges. Here, your sine domain is -1 to 1. That comes from your graph going up and down. Oh, sorry, I said that backwards. So sine range would be 1 to 1. Your sine inverse domain is 1 to 1. You can think of it here. This is your standard sine graph, right? So your range are coming up to +1, down to -1, up to +1, down to -1, over and over again. But if you think of when we found like inverses before, you switch your x and y's on your function. So because we're doing a sine inverse, you flip, and the range of your original is now the domain. So sine inverse has to be plugging in numbers from -1 to 1. Same for cosine, and then tangent is -∞ to infinity because your graph is something like this. So your range to begin with is infinity to infinity. So here's another true false for you. Try and think about why. So this one is true, you just cancel whatever. This one here is going to be false. The reasoning being, this is going to still give you 30. If you think of it here, sine of 30 is a half. So you get sine inverse of a half. And then sine of 150 is also a half. And you can't have the same thing equaling two different numbers. That can't equal 30 and 150. That doesn't make sense. Or here, all of these equal a half. So sine inverse of them. Your calculator, if you type it in, which one does it choose? It doesn't know, like, do you want 30? Do you want 150? Do you want -330? What's going on? So for like simplicity and to keep it like all in one chunk so you know what to pick, you are going to get a range of -pi to pi. So it's this half of your unit circle. The reasoning being, if you go to the other half, then you start repeating values. So it's not like sine inverse of 150 doesn't exist. It's that your calculator is going to give you 30 because it can only give you one value. So it's going to give you the simplest, smallest value rather than like giving you like -330, which doesn't really make sense. And the same with cosine and tangent. So cosine is going to be the top half because, again, it's the x values at the bottom of your unit circles when it's going to start repeating. And tangent is still going to be the right half. So to kind of talk through that, if you look at your unit circle here, sine is your y values. So here on this right-hand side, all of your y values are unique. They're all different. If we go over here, now you have the same y value, and the calculator wouldn't know, should I give you 60 as an answer or 120? So you pick this half because that's your nice, simple chunk of values instead of having like this part and this part that are still different, unique ones, but then you have two separate ranges. Here's what your graph would look like. So then if you take this chunk and reflect it over the line y equals x, you get what your new function would be, or the inverse function. Cosine, same idea. You want the top half because that's where your values don't repeat and you get a nice chunk. Here's what cosine looks like and the graph of arc cosine or cosine inverse. Here are your values of tangent. Again, same idea. You want the part of the circle where you're not going to repeat values. This is what it looks like. So your original tangent and then your arc tangent. And so then how do we actually use this or do something with it? So here we're going to draw a unit circle for each. So we're trying to find sine inverse of -√3/2. Draw your unit circle. And then sine is always on this half. So draw which half of the circle you're looking at. And now look at the value. Since we have a -√3/2, we have to be down because it has to be negative. And then think of where sine is. Sine is a y value. So you're going to get -√3/2 right there. And again, remember, we're doing sine inverse, so we're looking for the answer to be an angle. So I want to figure out what angle would give me this triangle where I have negative root 3 over 2 down here. So this angle would have to be a 60 degree or a pi over 3. And then you can think here, it's not in this top half, so it can't be positive. It's down here. So your answer would be negative pi over 3 or negative 60 degrees. So try these next two, and then I'll talk through them. Okay. So cosine, we have to be on the top half. And then look at what's your sign. We're a positive sign, so you have to be on the positive x side. And then cosine corresponds to your x value, so you know this is root 2 over 2, which makes this a 45 degree angle. So your answer is going to be pi over 4 or 45 degrees. A note here, if for some reason you were over here, you'd have to then adjust your value. So like this would be 45 or something, but then you have to figure out what's your actual angle from that. So your answer would be 135 or 3 pi over 4 instead of 45 because you're on the second quadrant. So the last one here we have tangent. Tangent again is on this half. We want when tangent is 0. So tangent again is your y over x. So you want to figure out where is y over x 0. So right here we have 1, 0, 0, negative 1, sorry, positive 1. On the bottom 0, negative 1. So at these top and bottom we're going to get undefined because we're going to be dividing by 0. Over here you're going to get 0 over 1, which is 0. So we need to be at this chunk to get the correct tangent value. So your answer is 0 degrees or radians. And that's it. So check online to see what your assignment is.